Anyone I missed that hasn't introduced themselves and would like to, please do. Benjamin, have you introduced yourself to the group?
Oh, probably not. I am Benjamin. I'm an independent machine learning researcher, mostly focused on computer vision, but like to dabble in NLP.
Nice. Cool. Glad to have you. All right, let's get started then. I think as you all know, today we're covering a code review paper. So I can go ahead and get started with that presentation. Yeah, let me find the tab. And also please do share if we were trying to gauge interest on like topics for month-long deep dives. I think there's a lot more work in this area, so as we go along, please feel free to like either suggest other papers or follow-ups you want to do in this area. Okay, let's get started. So today we read Automating Code Review Activities by Large-Scale Pre-Training. Very straightforward. Essentially, it's working on the problem of how can we automate code reviews. So the paper makes a few like large contributions. I think the first is kind of standardizing and pulling together a large data set of code reviews from like the top repos on GitHub that have like public comments, public pull request data, and the subsequent commit history. So they compile all of that kind of code review data, and then they also fine-tune several new pre-training tasks. So essentially, as opposed to just code generation, there's kind of the new nuances that it needs to learn in terms of how code is added, deleted, what the comments mean in relation to code changes that are made or not made. So the paper then dives into some of the newer kind of pre-training tasks that it used in order to kind of get used to the new data format and understand how comments play into code reviews. And then after that, they make some changes to like the training process and then evaluate it on various different tasks. So that's kind of the paper overview. Yeah, and they show like improvements over the basic T5 and Codex models for doing this task. And also their code and the data set are open source, so I think that's a good way for us to be able to like play around with it and see what can be done. Yeah, so the Eichler blog post, I think it just finished. We'll try to get it together for next cycle. Cool. All right, so as I mentioned, this paper focuses on utilizing pre-training techniques for tasks in code review. It builds on a large-scale data set. Raised their hand. Chung, do you want to ask a question?
Oh, I didn't know it was too invasive. So like, like code reviews are like kind of like these things are automated pretty well, like without like large language models. Like, is there like a premise why like a large language model would do these things better than like existing or is it just talking about like the code reviews that we write like without testing? Like it's like the initial like GitHub code review, is that type of thing?
No, so this is, what do you mean by automated? This is right now trying to reflect the process of I put up a code change. Someone reads through my code, leaves comments,
Yes.
and I update it,
I
right?
understand it now. Like I was talking about like existing code, like there's a lot of like testing and like like unit testing and like it seems to work pretty well, but like I guess for new code that's coming in, like it needs more review. So yeah.
Can I make a comment on this?
Sure.
So what this model is trying to do, as you can see on slides 15, 16 down there, you're calculating the weights of the changes, right? So your big model pre-train has a lot of knowledge. So now we are trying to find a relationship between previous code with new code with a pre-trained model and calculate weights on top of these pairs. And then given the weights, the model focuses attention of whether or not that change is important or not based on the comments it distilled knowledge from.
Yeah, so just to clarify, this is for the live review process. So it's not going back through old code and trying to leave comments. It's whenever someone makes a new change and is trying to get your change merged into master. Right now, pretty much, I think most companies follow a process where someone else needs to go through your code, kind of give you a stamp, and then based on that, you kind of are able to merge into master. So yeah, this is just kind of seeing if you can get a large language model to read through your code, leave comments, and get you to fix it, as opposed to having someone else on your team do that process. Does that clarify your question?
Yeah, thank you very much.
Yeah, anyways. So yeah, as I mentioned, they build this data set across 9 different languages and open source GitHub projects. The main two contributions, I think, are the new pre-training tasks and how they kind of format all of the code, review comments, and iterations into that, as well as the different tasks that it's evaluated on. So they change it onto 3 different things that kind of model the life cycle of a code change. So the code change quality estimation. We'll go into more detail in a minute, but high level, this is trying to determine if this code change requires like a blocking review or not. Like, is it just small changes that need to be made, for example, semantics and comments, etc., or is there some blocking issue? So that's more of a binary classification. Then the review comment generation. This is essentially what to generate the review comments. And lastly, taking the comments, taking the code, and actually refining the code. So they split it into these 3 different tasks and kind of treat each of them as independent problems. And each of the pre-training tasks that set it up are built such that it like best performs on these downstream tasks. For those of you who just joined, just a overview, we are going over automating code review activities by large-scale pre-training. Essentially, this paper is looking at how can you automate the code review process that currently like a human or someone on a software engineering team handles. Okay, so yeah, these are the 3 main tasks. So code change quality estimation aims to predict whether the code diff needs a review comment, and it assists reviewers to pick a code diff chunk that might have issues amongst a large number of code chunks. So it goes through the diff and essentially identifies potentially problematic changes. The review generation actually generates the review, so goes through each of the code chunks and figures out what's the best comment to make. And then code refinement takes the code chunk as well as any comments provided and aims to refine that code. So pretty straightforward. It's just kind of decoupling each of these components and treating them independently. Yeah, you feel free to just ask your question. I can pause.
Yeah, I think the couple of things that the authors can do on top of what they've done. First thing, amazing paper, is like really having like a Flesch-Kincaid scale. So that's a scale which measures the complexity of a prose, right? And whether it's readable by someone who is 8-year-old, 10-year-old, or 20-year-old, or so forth, right? Like, and see how it's measuring the generated model, code reviewer model generated code is comparing versus what others have generated in the training set. Yeah, I didn't see that.
What was the scale that you mentioned? I didn't catch.
It's called Flesch-Kincaid scale. Let me send a link. It's measured for like so it's a readability test score. So how readable a particular section of prose is, right? Like basically numerically evaluating complexity of reading a segment of text. Right?
Is this well adapted to code, or is it primarily for like literature?
It's primarily for, say, SEO. So for search engine optimization, it's actively used And
it.
so even for readability, like whether it's even if the machine say the 12-layer model, code reviewer model, they generate informative priors or informative data, but if it is harder to read, if it's like a generation is lines and lines of code comments, review comments, may not be as helpful, right? So where is the complexity of generation captured versus even a one-liner LGTM, right? So yeah.
Got it. Okay. This probably corresponds to, they do have evaluation metrics on kind of the quality of comments generated. So it seems like this might be another metric. But I think, yeah, it might be good to look into how well this adapts to code, because I feel like if it's not trained on code, it may or may not translate too well. Yeah, cool. Nice point. Okay, so as I mentioned, there's 4 different pre-training tasks. They really kind of leverage a lot of pre-trained models. So this whole thing is primarily based off of the T5 code review model. So this is a T5 model. So that's the text-to-text training model, I think, by Google. I don't remember. But they leverage that, which is a standard encoder-decoder transformer model. And they take it pre-trained on that. So they take the T5, I think it is. Yeah, there's this one. There's one that's pre-trained on, it's called the Code T5 model. So they use that as the pre-trained model on which they base all their experiments. Yeah, it's a pretty, I think it's a medium scale model. And they show that does have some limitations. But the 4 pre-training tasks that they use are 1, diff tag prediction, 2, denoising code diffs, denoising review comments, and then review comment generation.
We're small model, huh? We're small.
Yeah, it's relatively smaller. And I think they also run a few tests with T5, which is even smaller. I think it's about 60 million parameters. And they're able to show, like, yeah, at that point, it does not generate meaningful comments anymore.
I mean, this size model compared with other one is almost nothing.
But that doesn't matter. It's not about the size of the model, but it's about the strategy and the problem solving. Like the semantic BERT model would work here too. And it's also like you can train it up to 200 million parameters and it still be enough to get the knowledge and the relationships you need to do the code review.
I guess it's also depending on the domain. Maybe coding is more structured than natural language. Maybe that's why it's easier to capture, the thing from the coding than from language. I guess that's another reason.
I think also, to be fair, they're comparing against different baselines. So you're trying to see the relative improvement on, let's just say, T5 as is and T5 trained on each of these different tasks. And then you can plug and play with the different baseline models. Okay, we'll go into each of these in more detail. So the main contributions are 1, the pre-trained model that takes code diffs as input and is able to generate review comments and identify problematic chunks of the code. Pre-training tasks for better code change generation, and then this large data set for code review. So this is kind of what it looks like. So they've taken all the pull requests in from GitHub, the code diff with and without comments. So this kind of plus minus format is something that they pulled and extracted from GitHub and included in their training data set. So this identifies lines that were asked to be removed or added versus kept. And then after it runs through the code reviewer model, there's a 1 or 0 for code diff quality estimation, review generation, which is a generative model to actually generate the comments. Code diff quality estimation is binary for 1, does this need changes or is it good as is? And then the code refinement takes in the code, takes in the review, and then generates the updated code. So these are kind of the 3 tasks or 3 steps in the process that they use.
So it's the same model for all 3 tasks and not separate models for each one of the tasks.
So it's the same T5 model. So essentially they take this model, they pre-train it on all of the 4 pre-training tasks, and then they have different loss functions for each of the 3 each of these 3 tasks. Because one of them, as you see, is binary classification for the code diff quality estimation. The second is just a straightforward kind of generation task, and the second one they call it as like multimodal because it's taking in the code as well as the review in order to generate a code change. So yeah, those are all kind of different loss functions, but they use the same model, this T5 code model that they pre-train on each of these different tasks, and then yeah, they use that with the different loss functions to generate each corresponding task.
Okay.
Yeah, so this is just kind of another example. So for each statement, they either determine if a review is needed or not. And then if it does, it generates the code review. And after that, it actually takes that and makes the update. And each of these are kind of done sequentially to follow the process that normal users follow. A code reviewer is just someone who's reviewing code. They're just trying to automate that. Instead of having a human read the code and leave comments, it's trying to get the model to be able to do that. All right, so as mentioned above, code change quality estimation is the binary classification task to figure out if code is high quality or not. They just determine 0 or 1. If there's no significant change, it bypasses the rest of the model steps. Code review generation. Yes, I agree. The code review generation output is a predicted review comment where WI is natural language word and N is the length of the review comment. And code refinement, the model takes in both the original code and review comment and the target and revised code C2 and outputs the target revised code. So I think they put in a lot of effort into building this code review dataset. There's a format called the ETCR, which is an infrastructure that they've leveraged in order to mine code review datasets. And they use different web crawlers to collect the PRs, the commits, comments, and source files. They do make some reference to how a diff or a pull request can have multiple different commits and have iterative comments. I didn't see well how that was leveraged in their paper. So it looks like they might have just collapsed all the commits and looked at all the code at once and then kind of handled it. And then they also have a data store that they used in order to store all the metadata on pull requests and comments, including the hashes, the changed file names, etc. So this data set would be good to explore to see like what other things could be leveraged in terms of understanding how this could be improved. I think they've done a good job in kind of pulling together this large data set for people to work with. So as I mentioned before, this is really built on the Code T5 model, which is the text-to-text transfer transformer. Relatively small. Yeah, they kind of leverage this for all of their baseline models. The input-output representation is something that this paper kind of builds into their data set that they created. So they have special inline tags, negative and plus, for indicating line deletion and line insertion. And they're replaced with special tokens delete and add, and keep for each unchanged line. And a message token is inserted to separate sequences between code and review comment. So it kind of pulls all of that information and creates a data set that indicates what was changed, what is non-changed, and what's a comment versus not.
So one critique I would, if I may add, for using the ETCR database is that one is actually circa 2021, right? And there are many, like say, zero-day exploits have been discovered since 2021 to 2023. So if a model is trained based on code reviews, whether the efficacy of a particular code commit is okay or not based on a historic data, but not the most recent data, there will be biases towards commits which are marked as thumbs up, but it shouldn't be.
Okay, in my understanding, it was I didn't know ETCR was its own data set. I thought it was just a
No.
system for mining code reviews.
Yeah, so, ETCR is basically, that's the paper, right? Like the exploit these code reviews. So bigger data for deep learning. It's a Germany-based authors who have shared, the infrastructure for. Yeah, so I did not see exact clarification from authors about what was the duration of the data. And it's a generic comment that, even if, CISA or other entities regularly report codes which are malicious or which have potential harm, right? Like, and the model is not accounting for that at the moment, right? Like that, whether this particular code commit has been subsequently verified to be malicious or not. There's no check for that. So a model may say, yep, it's all good, but that may not capture subsequent info.
I see. Okay. Yeah, I'll take a look at that paper. I haven't taken.
Aishwarya, I have
Yeah.
a quick question.
Mhm.
Does the paper mention, like, that it compares like 3 other models, like some transformer T5 and code T5? Do they like fine tune these models for the changes that they've done, or like do they like do like just they don't do any of that?
I mean, essentially what they're doing is they're taking code T5, retraining it on these 4 tasks, and then evaluating it on the 3 tasks. So
I see.
I
I'm just
I
talking
think
about
the main contribution is like it's
Okay.
it evaluates code T5 as is on these
as
3
is.
tasks,
Okay.
and then it does it after it does kind of these 4 pre-training things that essentially should get it to understand the code review format better and so forth. Is that what you're asking, or?
Yeah. I feel like they've added a lot of like peculiarities into their data that like unless it's like fine-tuned specifically for those things, like it might not be like an apples to apple comparison. But thank you for clarifying.
Yeah, I mean, I think they did this so that it can better understand. They mention this in the paper regarding how, kind of having comments in your code or like reviewer comments that aren't kind of identified as such doesn't perform well, right? Because a model will not understand to distinguish what this is doing. So that's why they have each of these fine tuning, which we'll go into a little in a bit, so that it can kind of really understand the code review diff format better when performing each task. Yeah, so we'll go over the first one. The first one is the diff task prediction. Pretty straightforward. It's they mask out each of the addition, deleting, and keep tags, and then they teach the model to predict these. So learns code diffs as a special format of source code for the code diff scenario. They call it DTP, teaches the model to understand these line tags, and they train model to predict these tags after masking them. So this kind of teaches the model to understand whether the code review thought a line should be changed or unchanged. And this kind of directly feeds into that binary classification task. And this, as you can see, is pretty much a very straightforward cross entropy loss, where it's trying to predict the probability it's one of these 3 tokens. Yeah, any questions about this? Pretty straightforward, honestly. Yeah, it's they just kind of really broke down the entire process into multiple components and try to tackle each one. Yes, Andrew, I think you had something.
Yeah, I have a really silly question about init for the new tokens. Do they detail the methods they use when they're adding like new tokens and just initting and so forth? I was just looking for the actual code link also, if someone has it.
Yeah, I mean, I think this is a part of their data set generation, because when they're pulling all the commits and the corresponding PR data, I'd imagine they're, translating what's encoded in the UI as like the negative and plus signs and just adding the corresponding tags. Yeah, it might be in that section, or if you look at the data set extraction part, it might be there. That's what you're asking, right? How they actually converted from the PR to this format?
No, I mean when they're adding a new token, what init that they use when like for the actual weights of that token in the output.
Oh, I see. I don't remember reading that.
As far as I know, whenever such thing happens, they usually create a new embedding for that with a normalized, like an average embedding of all the embeddings they have in the vocabulary till then. And then when they train the model using this pre-training task, the model will automatically learn the embeddings for these tokens. So they just start either with a random value or with some normalized value of all the other embeddings that they have. That's the general way of doing it, I think.
Yeah, I think that would make sense. Cool. The other one is the denoising objective. This is pretty much reminds me of just BERT, essentially. So they randomly mask out various different, or they corrupt different spans of text, and they have the model predict these spans. And they do it both for denoising code diffs as well as denoising the review comment. And this kind of teaches it to better understand how to generate code review comments, as well as which parts of the code were identified for review to begin with. So it's unsupervised pre-training objective to kind of better understand or distinguish between reviews and code. So the original objective randomly predicts spans of the sentence with a corrupted rate of 15%. And by learning to predict these, it gains general knowledge about the corpus distribution. And yeah, since this is a generative task, it tries to determine the text given that it's been masked. Yeah, and it's a log likelihood over all the possible words that it could predict for this masked token. And then the third one is model pre-training for review comment generation. So this tries to actually capture the relationship between the code changes and the review comments. So they approach this as a conditional generation task, where the model is given a code change as input and asked to generate the review comment written by the human reviewer. So they use a negative log likelihood loss, where they take both the code as well as the they take both the code as well as the comment, and then they try to generate the code change based off of both of those inputs. So yeah, again, same thing, but it's like conditional generation because it's conditioned on both the code and the comment so far. Any questions about either of those two tasks?
So here the comment generated is not from the model, it will be already present in the data set, right?
Yes, so I think what it's doing is it's given the code change and it's asked to generate the review comment written by the human reviewer. So yeah. I think this is backward actually. So it's taking the code change that was actually made. So after putting the comment, someone changed the code, and then they're using that code change that was made to predict the comment that was used to generate it, is my understanding of this. Because they're given the code change and then they're generating the comment. Because if you look at the bottom line, W less than T is the live generated comment for this code change.
Okay. Okay.
Yeah, I guess I don't know why they chose to approach it this way. But yeah, I guess the other approach would be given the comment and given the code, generate the code change. But it looks like they don't have any tasks that are actually generating code. So it might be easier to work backwards and just, I think, yeah, that's probably why, because the T5 model isn't generating code in any of these examples. The first one is binary classification. The second one is generating the review. And then this one is generating the review given the code change. So it's not generating code in any of the training tasks. Okay, so now this is kind of going a little bit more into all of the data that it used. So this is the data set that if you want to look into, it has each of these different languages, number of projects, number of pull requests, data, number of comments and no comments. So it's a pretty comprehensive data set from what they've shared. And then they split this entire thing into train, valid, test, and lines of code for each of these different tasks. So the first one is quality estimation, review, comment generation, and code refinement. The reason the last two are like smaller is just because there's a lot of lines of code in the data set, and only I think looks like about 10 to 20% that have comments on that code. So they evaluated on all of these different questions, metrics. So the first one is performance on code change quality. This was the binary classification task for needs review or doesn't need review. So since it's binary classification, they have precision, recall, F1, and accuracy. So comparing code reviewer against code T5, and transformer, they're able to show improvements. So as I mentioned, the main difference with code reviewer is that it's kind of pre-trained on each of those 4 different tasks, so it kind of better understands the code review format. I don't think they make all that many other changes. There's a few things that the paper mentions about fine-tuning after pre-training. But I believe, yeah, I don't know if they did an ablation on each of the different pre-training steps. But yeah, so this is the first kind of task, trying to predict which code chunks need review or not. And they, seem to show it has higher precision and recall. This is an example of the actual review that are generated. So they seem to use blue for kind of the main metric for evaluating the reviews that are generated. So blue, as well as what's the other one?
Rouge.
Perplexity?
Rouge, yeah. Yeah. Perplexity, I haven't seen perplexity being used as much on text. I've generally seen Rouge or Rogue, I think it's Rouge, being used the most, but this one uses blue instead.
Yeah, they use blue and rouge to test the generation quality of text. Perplexity is for like how good the language model is on prediction of tokens.
Got it. Cool. So yeah, if you can read this, essentially it's just showing the ground truth was this change prevents a user understanding how their server is configured. It's a very trivial change, I think. Just looking at the log comment type or logging level. And then T5, code T5, codex, and code reviewer. and they look at the different blue scores. I think in this specific example, Codex has a higher blue score, but it looks like the comment doesn't make as much sense. So that's like another open question, is how relevant is blue for this as a metric. And then the other example is similar. You can probably read it yourself. It looks like, I don't know how much this is cherry picking versus not cherry picking. Would be good to kind of just try it out ourselves and see how it does. But yeah, as you can see, these are examples of comments generated for various different. I don't know if I can. Actually, maybe. View. No, that's not. Does this help?
Yep.
Yeah. Okay. So yeah, as I mentioned, you can read through this. The paper has a few more examples on the different reviews that are generated between each of the comments. And the third one is code refinement test. So it produces higher blue score than the baseline models. Here, as you can see, it's actually looking at what the code should be. So we have some suggested improvements / removing lines of code. Yeah, that is all for the presentation. Any questions?
Could I ask a question that might be a little silly, please?
Yeah, go for it.
On the benchmarking slide, I think it was like 2 or 3 forward. Really nice talk, by the way. I really enjoyed it. So thanks for all that.
Yeah, for sure.
So it was the one where it was comparing the T5 to what they done. I was just curious, just to be a devil, yeah, this one. If just to be a devil's advocate, is it really a fair comparison? Because don't they, from what I understood, they take the T5 and then they use more compute to basically learn more structure. And so, in like a devil, in one mental model of it, if you double the amount of compute used, then it doesn't make it might make sense that they do better. Is that not what happened?
So I don't think the code reviewer versus T5 with fewer encoder decoder layers is a fair comparison at all. But I think versus code reviewer versus code T5, as I mentioned, so code reviewer is taking code T5 and then it's just pre-training it on each of those 4 objectives that we mentioned, right? So that comparison is essentially looking directly at how well pre-training it on each of those 4 tasks that we mentioned, kind of the masking of the add, delete, update tokens, as well as masking the review, like each of those 4 that we went over. So this is essentially making that comparison between the 2.
Awesome, thank you very much.
Yeah, they use the same model size as exactly as it is in code T5 here. And it's pre-trained on the same code T5 data. So yeah, I think from what I understand, they're holding everything else constant except changing the pre-training and fine-tuning on their new data format and so forth.
Perfect, thank you very much.
Yeah, and I think there is another question in the chat. Yeah, I don't think I included the tables for this, for both of these in favor of kind of these examples. The paper does include the comparison metrics on the blue score. So yeah, either I can try to find that in the paper and share it, or feel free to take a look. Yeah, how about we spend the last few minutes to just brainstorm any suggestions or improvements, and also if people have good follow-up papers, we can discuss that. I think, as probably everyone knows, this is a very comprehensive problem for anyone who is a developer. So
Excuse me.
Yeah.
In the is code reviewer generating code in the third example?
That is a good question. Yes,
Because you earlier said that it was not generating code.
yeah, because the way that they defined this task, right, review comment generation, it does not seem to be generating code. But that being said, they do have a code refinement task, which is yeah, let me double check. Unless there's one more task that they've included. Okay, so the code refinement task is computing the blue score between generated code and target code. But then let's see. They don't seem to include that in their model architecture. So they have the diff tag prediction, the denoising objectives, and review comment generation. Neither of those actually generate code.
Yeah, so they might be doing a separate pre-training task, and for the final third task, they might be actually generating code from that model, base model.
Yeah,
That's
I
also
don't think
possible.
it would it would be a big deal for if the model is already doing the review. I don't think it would be a big deal for the model to generate code as well. And why would you not want it to generate code? Like you're already using the compute, right?
Yeah, that's actually interesting because if any of you take a look at the paper, in the model architecture section, they are not actually talking about any task. So I guess the pre-training tasks don't generate code, but then one of the training tasks is to generate code. So they're probably not pre-training it on that task. Yeah, I
Yeah,
think
that's possible.
that's what's going on.
Yeah, section 2.4 of the paper that's covering code refinement, and it says, yeah, that's it. It uses the original code contributed by the written by the contributor and the comment, review comment, to generate the C2, which is the proposed code refinement.
Yeah, but doesn't look like it is. So that's one of the tasks that it's evaluated on, but I don't think they've actually pre-trained it to improve that process at all. It looks like they're just using that out of the box. So I guess the approach then that they took is that each of the pre-training tasks is just to have the model better understand the format, like understand code, understand the. Okay, actually that seems reasonable because each of the two denoising tasks, it was to better understand the difference between the code, the comments, and the generated comments. So that's probably what they used in order to see if it can improve this. But yeah. Actually, yeah, to be fair, I don't know if the denoising was on code either. They have denoising code diff. Okay, this is probably the actual code. And then denoising the review comment is the generated text. Yeah. Cool. Yeah, so I think the thing here just to kind of distinguish what are the pre-training tasks to get the model to better understand this code format versus the three main tasks that they evaluated on, which are separate from pre-training. Okay. So yeah, one of the main tasks it evaluated on was code refinement, which is actually generating code.
It's a great paper though to discuss. Yeah, I wonder like if they're like tracking the SOTA on this, like because I try to look in papers with code or others. It would be great to like track this. So
Yeah, I mean, I think I'm pretty interested in this area too. So if we have follow-up papers that I haven't looked yet, but would be good to look at how this is improved. I think this paper was published, let's see, October 2022. So there's probably been a few months of work on this since.
I'm curious about their choice of using custom tokens versus just keeping the diff format as is. Since this is something that we've been doing just with pre-trained models, like generating diffs. I would love to see ablations of that.
I see. I mean, how would they do that? So I think the diff, you saying just keep the positive, negative signs in terms of instead of replacing the tags, because I think this is like part of the UI in GitHub. So it's probably not directly a part of the text as is. So that's why they made this decision to be able to mask them. Also, I
I'm
think the
assuming that,
main
like,
benefit of that
Git
though is
commit
like,
itself sorry. I think the Git commit itself contains those plus and minus as like the patch format that Git uses.
wouldn't it be beneficial to have, because otherwise wouldn't it possibly mistake those with plus and minuses in the code already? Like assume that the code has additions, you know, these are normal sequence characters, right? That can live in code. If you leave those as is and without introducing the new tokens, isn't it possible that those are mistaken with the normal usage of those tokens in code?
Generally, no, because the diff format accounts for that. And we've seen good performance with GPT and like, 3.5 and up models that in that domain without any special tokens.
Okay, interesting. Do you know what the diff format provides for those tokens instead if it's not the normal plus minus?
It's just plus minus, but it's avoided by the way that you have spacing and so forth, just in like git diff and so forth, and patch format. I think there's
Got
a
it.
number of slightly different related formats for this, but overall they have the same concept.
Sounds good. So it looks like you might have worked on this yourself. Can you share any learnings you've had in this?
I think as a whole, we're trying to leverage as much like large pre-trained models. So we're trying to find creative ways to turn it into just a text-to-text task without like fine-tuning, adding custom tokens, all this, which definitely can help performance, but also impose like significant infrastructure complexity and so forth. So I would just say that yes, it works to do this sort of thing, like with GPT 3.5, and I would love to see just a comparison against that.
Got it. Did you by any chance use their data set, or have you kind of scraped your own for this?
We're interested in this in a slightly different problem domain, so I haven't actually run any evals.
Got it, got it. Yeah, I mean, I think my most obvious question as a follow-up is why are they using T5 to begin with? I know that they have evaluated codecs, right? But you could obviously train this on a lot more newer models, and I'd imagine you would get better metrics overall. And I also think something that's missing, I know this is kind of hard to do. T5 is better for embedding. Why is that? And why would the performance of T5 be better than a different baseline model, for example?
Is a smaller model, right? And the way how the model trains, I believe, is like you do semantic pairs. So is the strategy how to solve the problem with the size also, they increase the performance. I need to pick where I read that. But people is using T5 for semantic relationship extraction. So you can do semantic embedding. And they use database even like to increase the corpus of data they can get. They use like Pinecone, something like that.
Okay. Yeah, might be worth looking into.
Like if I remember correctly, I'm probably wrong, but I once heard that like unlike the BERT models and GPT model which only uses one of the encoder or decoder, T5 actually uses both. Maybe I'm probably wrong. But
No, that's true. T5 is an encoder decoder model. I'm just curious. Yeah, so okay, I guess run on to your question. In which scenarios is T5 more performant than like a encoder or decoder only model architecture? And why is that relevant to this code change or code review problem specifically?
Yeah, I read somewhere that like because it's in certain situation it's better to have both encoder and decoder and like only one. I don't remember specifically, but there is some reason.
Also using T5, T5 generally has very good generation performance. Like you have BART and T5. T5 is usually, since because it's encoder decoder, you can actually easily generate novel sequences. Like a review would be a different kind of sequence each new time. So T5 is good in generation generally. Yeah. That's why they maybe started with T5.
Wasn't it more like to do like some comparison between like a previously like trained model on code? Like it's code. They're trying to compare it to code T5. Like, you know, like their baselines are like the transformer and just like a vanilla T5. So like I feel like I guess the intention of the author was to have a model that was specifically used for code reviewing tasks and then like to compare against it. So like it makes their like model or like the paper more significant.
Yeah, they do mention that Codex doesn't do well on this because it has never been trained. It isn't like pre-trained on any code review data. It's only used like code files in the raw format. So that's why it doesn't do well on this test. So that's probably why they, yeah, as you mentioned, chose another model that has been trained on code in this. It would be interesting to also check what the code T5 model's training data looked like. Yeah, it seems like it's collected from Stack Overflow and Code SearchNet. So I think that's probably why. Okay. Yeah, so I think that's the main question on like why they didn't fine tune Codex, I think. And also, I don't think the model is actually open source. So it's probably another reason why. Cool. Good questions. Yeah, I think a good follow-up for this is if anyone's interested in like follow-ups, I think as we mentioned, it's probably about 5 months worth of additional work on this field area. Please add any follow-up paper suggestions. And also this code repo is public, so if anyone does have time, I think we've always kind of brought up this idea of run it and test it out so that we can get a better idea of kind of the gaps and areas for improvement.
The calendar says that at this moment there's an MLC Open Clubhouse meeting.
Yeah, that's run by I think Roseanne, or it's not directly affiliated with the NLP reading group. So yeah, if you want to join that, I don't actually have too many more details. You can just go ahead and check it out.
Okay.
Can we do some study in using benchmarks for model lifecycle with Kubeflow? Do you want to elaborate a little bit more on what you're looking for?
Yeah, so a big issue like when you deploy like on a production environment is that we need to do the life cycle. And then people set up like either with Airflow, Kubeflow, MLflow, there's a bunch of tools to do it. But it's a little challenging to keep on top of the benchmarks and how to properly design a life cycle so you keep a production model running like with a good performance.
Would the performance deteriorate on its own? Because I'd imagine something trained on like code review data sets not going to need to be redeployed every week, right? Because code doesn't change that much.
well, not code review, but suggestion engines like chatbots, like
Oh, so
business intelligence.
you're asking about something completely tangential then, right? Or like not directly related to this paper.
Oh yeah, not related to this paper, but the strategies they apply similarly across like NLP.
Yeah, you can. So I guess is your question, are others in this group interested in looking into that? Or is that what you're asking? Or are you asking, what exactly is your question?
Oh yeah, if others are interested in doing this, so we can, make better models.
Got it. Yeah, worth putting up the question. I think that goes more into the research engineering domain of this. It might be good actually, now that we have like about 20 people attending, to kind of put up a poll on where everyone's interest lies, like who's more into the science/research, who's more into the engineering, who's more into applications/productionalization. That way maybe we can help identify, clusters of people who want to work on different parts, because yeah, there's very different domains. Even within engineering, there can be the small scale, just pilot test out, versus I guess what your question is more like large scale hosting/productionalization. So different subclusters of interest. Yeah, we can try to put up a poll and better identify that, if that is helpful.
Are we going to be out of a job because, code generation, code review? I mean, I'm kidding, but of course not. But I'm thinking there should be some maybe paper or whatever research about what such tools can help. In particular, the new wave of code generation and code review based on the transformer language model, what they can do and what human being will be doing. I hope maybe there are already such paper already.
Yeah, no,
Yeah,
that's a good
we-
point. I think, yeah, go ahead, Akash.
Yeah, I was saying we'll be out of jobs next 5 years, but not now.
Yeah, I
But
think
yeah,
within 5 years.
yeah. But there was one paper that we were considering for reading next week. It was like how good ChatGPT actually is and what it does wrong. So that is one area that we can look into, like how these models that are coming in, what do they do wrong actually? So that might give us a perspective of like where the humans are still better. If that would be interesting.
Yeah, I mean, autonomous machine intelligence is different than having machines be able to write code. I think this is assuming most people here are in some form of software engineering/research engineering / maybe, I don't know, research scientist. Maybe, I don't know if it can write its own models, but I think there's definitely a lot of room for just automating writing tests, automating writing boilerplate code, reviewing code, testing code. A lot of the basic tasks. Yes, don't worry, we're not saying it's going to happen right away.
I saw a post today which said that ChatGPT cleared a Google level 3 interview. I don't know if it's correct or not, but yeah, our jobs maybe in 5 years. Yeah.
So I also linked in the doc. I think this is something I wanted to do a few weeks ago. Is there are a variety of kind of projects that I've been exploring, kind of along these lines of automating various parts of the code lifecycle, as well as a few other things. Yeah, we can probably put this up as more of a poll to everyone in terms of better aligning interests. But I think there's a lot of room just within the space of this kind of automated code generation. I don't know how familiar all of you are with tools like Auth, like the startup Auth. They're coming up with things called ICE, as well as LangChain and so forth. A lot of them can be really used to better leverage kind of the entire code development iteration process. So yeah, if people are interested, I'll try to put up a poll with kind of some of the projects / just interest areas. I think a really cool thing for this group in general would be to see if we can successfully pilot projects together. In the past, we have written blog posts. I think around last year, we submitted 3 blog posts to Eichler. But yeah, it would be cool. We haven't yet been able to collaborate on a project, but something for 2023, I think we can try out. All right, we are over time. So I think the main AIs for everyone here, if you do have papers that you think are good follow-ups to what we just read, please share in the channel and we'll kind of consider them for next week. Yeah, and I'll try to work with Akash to put up some sort of a pool to better gauge, subdomains / collaborations amongst everyone.
That sounds
Okay.
great. And thanks very much for
Thank you all
presenting.
so
It was
much.
really great.
Thanks all for joining. See you guys next week.
We were supposed to discuss about cramming also. Steve.
About what?
The paper that Jay discussed 2 weeks ago. So Stephen has been trying to do some experiments around it. So maybe we can stop the recording and then continue this meeting here for that.
Yeah, let's do that.